Callan here, helping you today with Chapter 3, Lesson 10, Solving Equations Containing Like Terms. All right, folks, go ahead and pause if you need. Take a look at the problems from the previous lesson and come on back when you're ready. All right, as I mentioned, we're going to take everything we've been learning from previous sections and we're going to go ahead with solving equations with like terms. Now, if I could bring this down for a little. Remember what we've been doing the last couple days, using the distributive property to say, look, 3f's, 4f's, together that makes 7f's. Okay, so 3f's plus 4f's, we could rewrite it. And from there, we have a one-step equation and we know how to solve it. Now, of course, we're going to continue using simplification with multi-step equations as time goes by. But for today, we're going to stick with solving equations with like terms, just two-step equations. Go ahead, pause your video, title your paper, and come on back, whatever the date is, whatever the assignment is, come on back when you're ready. All right, ladies and gents, I have a model here. Actually, we're going to draw a model for 7n's plus n equals 56. So first things first, let's go ahead and get 7n's out here. 1, 2, 3, and 4. Let's just make a nice big column of them, shall we? 5, 6, and 7 is what we need, but wait a second. We further have another n, and frankly, I'm kind of a 1 guy. I'm going to write a 1 in. So 7n's plus an additional n on one side is equal to 56 on the other because that's 56 positives. But again, why write 7n's plus a single n when I could simply say, well, look, Mr. Callan, we got 8n's equals 56. Naturally, we don't want to know what 8n's are. We want to know what a single n is. So what can we do? Well, if we split each of these into 8 groups, and I guess I could have gone all the way across, huh? According to our model, each n appears to be positive 7. How do we write that with numbers and symbols? Well, we're splitting into 8 groups. We're being fair to both sides. Naturally, 8/8 gives me a whole n, and 56 divided by 8 is 7. Or is it? Now, ladies and gents, here's the deal. Remember what we do? When we are checking, we simply copy down the original equation, 7 times some number n, add, well, the same number n, and it's supposed to equal 56. But right now we believe we know what n is. We believe n is 7. Notice again, I did not use 8n's because what if we accidentally messed up the combining of like terms? If you use the wrong equation, say you used 9 times n, it's going to look incorrect. So be very careful with that. Use the original equation. All right, now order of operations. I'm going to put a little question mark here. Is this true or not? Order of operations tells us to multiply first. 7 sevens is 49. 49 plus an additional 7, plus some of you even cover this up so your brain doesn't cheat yourself. 49 plus 7 is 56, and when that uncovers, when you take your finger, your hand off of it, we certainly have a true statement. So a couple things to remember. First of all, leave the original problem alone. Your work, your solution should be circled and some check. For the check, please recall, we're going to take the original equation, not our simplified. Take the original equation and ensure that our number works, that it makes a true statement. Don't forget order of operations. Multiply always comes before any addition and subtraction. And you can see a model why 7n's an additional n could simply be rewritten as 8n's. Some of us are 1 folks. Don't be afraid to put that 1 in. Let's take a look at 2 more examples. Pause, rewind if you need. Otherwise, maybe you could pause the video, do some of these examples on your own, and come on back when you're ready. Let's go ahead and start with example B. 44 is equal to 9t and 2t. But wait a second. Why write 9t's plus 2t's when you could simply write 11t's? Now, we don't want to know what 11 envelopes of money are. We want to know what a single envelope of money is. So let's go ahead and split this into 11 parts and split this into 11 parts. In this case, 11 11s does make one whole T, and 44 divided by 11 is, well, 4, I think. But we're going to go ahead, we're going to bring the original equation straight down. The original equation being 44 is equal to 9 times some number t plus 2 times some number t. We don't think t is unknown anymore, so I'm going to substitute in 4. And I'm just going to take my hand, take my finger, cover up that side. 9 4s is 36. 2 4s is 8. Remember, we go left to right because multiplication is equally strong. So that's why I started off with the 9 times 4 and then the 2 times 4. Then I'm going to go ahead and add those together. And look at there. This does in fact make a true statement. Now I'm going to do one more problem. I want you to, as we do these, examine these two problems, analyze them. How are they similar? How are they different? I'm a 1 kind of guy. Why write 1? Oh, wait a second though. 5 C's and 1 C is going to make 6 C's. We can combine those like terms. Meanwhile, let's split it into 6 parts so that we get a single C equals. After all, 6 6 makes one whole. No, you don't have to write the 1. Now, if this were 36 divided by 6, it would be 6 wholes, but it's not. So I'm thinking 6 tenths. Of course, you could have always come off to the side and gone from there. However, I have no fear because what are we going to do next? We're going to check it. If I divided wrong, I'm going to catch it right here. So we're going to write 5 times some number plus another one of those numbers, and we think those numbers happen to be 6 tenths. Cover up if you need so your brain doesn't cheat yourself. 5 times 6 is 30, but wait a second. We do, as a matter of fact, have one place value, so it's not going to be 30, it's going to be 3 wholes. If we add 3 wholes and 6 wholes together, 3 wholes, excuse me, not 6 wholes, 6 tenths, and lo and behold, this does appear to be a true statement. So again, a couple things you're noticing as you look at those two problems. Look at the blue, look at the green. First things first, why write 9 T's and 2 T's when you could write 11 T's? Why write 5C plus another whole C when you could write 6 C's? Simplify your life before solving. So we can simplify by combining like terms. Then in both cases, the inverse of multiply, we divided and we were fair to both sides. Not only did we circle our solution, but we then substituted in to check it. And again, to be very clear, we're going to take the original equation because I have seen some folks accidentally add wrong. They might write 12 T's down. And if you write 44 is equal to 12 times some number and substitute in, it may or may not work and you'll never know why the mistake happened. So use the original equation, same thing on the green problem. We use 5 times some number plus another one of those numbers. You may, of course, write a 1 there, but that won't change the game. Now, wrap this up. Pause if you need, think about this. Why are we grouping this together in a chapter of two-step equations? If you'd like, go back to those last couple examples. Step 1 was combining like terms. And then step 2 was eliminating the coefficient, in this case through division. So, as a matter of fact, these are two-step equations. That, ladies and gents, is why we brought this together into this chapter. All right, so go ahead now, whatever the assignment date and assignment number are, begin page 83. Do well, folks. Take care, and let's grow.